Dear students, today's lecture number 2, Toxicological Chemistry, Introduction of the Toxicological Chemistry, the subject, task, and purpose of Toxicological Chemistry, connection Toxicological Chemistry with other subjects, food safety and doping control, toxicological properties of narcotics, psychotropic and highly effective substances, objects and features of chemical toxicological analysis. Toxicological chemistry is a science that is directly related to both toxicology and chemistry. Toxicology itself is a medical science. Its name is derived from two Greek words, toxikon, poison, logos, science, meaning training. So, toxicology is the science of poisons, their properties and effects on living organisms. The definition of toxicological chemistry, which reflects a direct interaction of toxicology with chemistry, is relatively different. Toxicological chemistry is a science that teaches the method of analysis of toxic substances and their decomposition products in living organisms, in internal organs, tissues, biological fluids, and other relevant objects. Unlike other known types of analysis, the methods used by toxicological chemistry consist of the following continuous steps. Isolation of toxic substances and their breakdown products from the relevant research objects. Isolation is the process of transferring a toxic substance from the relevant research object to the liquid phase. For example, distillate, extraction, mineralization. If the toxic substance is contained in biological fluids, blood or urine, then the isolation consists of the extraction of the substance, the transfer from the aqueous phase to the organic solvent phase, which doesn't mix with water. Next stage, purification of isolated toxic substances from foreign impurities. For example, fats, proteins, amino acids. Many experts in the field of toxicological chemistry consider these two stages, isolation and purification operation, as one stage the extraction or separation of toxic substances, and presented it as such. Next stage, detection of isolated toxic substances, qualitative analysis. And last one, quantitative determination of toxic substances. As the full proof of toxic substances in the research objects requires the importance of these stages. The tasks of toxicological chemistry also increase and become more precise in stages. Toxicological chemistry improves methods for the isolation of toxic substances and their metabolites from research objects and develops new methods. It also defines the theoretical basis of methods of isolation of toxic substances from various objects. Toxicological chemistry studies the methods of purification of toxic substances isolated from research objects from foreign impurities and offers new methods for this. This subject improves the conditions under which previously known descriptive reactions are carried out for the detection of toxic substances and offers new reactions with greater evidence-bearing capacity. Toxicological chemistry improves the known physicochemical methods used to quantify the substance extracted from the object of research, if necessary, seeks new photometric reactions, and develops modern methods based on them. One of the most important issues facing toxicological chemistry is a comprehensive study of metabolites that are products of biochemical transformation of substances entering the body. Their isolation from biological system on the basis of experimental and model experiments study of physical-chemical properties, chemical nature and structure. Toxicological chemistry, like other science, has practical applications. As a whole, these are called chemical toxicological analyses. So, toxicological chemistry is a science and chemical toxicological analysis is its field of service. It's not allowed to confuse or equate these two concepts, toxicological chemistry and chemical toxicological analysis. Chemical toxicological analysis is a set of scientifically based methods used in practice for the isolation, purification, characterization, and quantification of toxic and violent substances from the object of study. At present, there are a number of sections in chemical toxicological analysis as the objects of chemical toxicological analysis and numerous and diverse in nature include not only toxic substances, but all foreign substances. Forensic chemical analysis includes the study of toxic substances contained in objects taken from the corpses of people who died from the effects of lethal dose of a toxic substance. This analysis is carried out by employees of the forensic chemistry department, chemist expert operating under forensic medical examination. Chemist experts can only be pharmacists with higher education. Next, laboratory diagnosis of acute poisoning includes the searching and studying of the exact substances, the biological fluids from the human body and vomit taken from the body of persons poisoned by the toxic dose of the toxic substances. This analysis is usually performed by chemist laboratory technicians in special laboratories organized at toxicology centers and large clinics. Next one, doping control. Increasing the body's resistance to chemical is called doping. These chemicals are called doping substances. Doping substances are secretly used to achieve an artificial victory or an opponent in sports competitions. The detection of these substances in the body is carried out through a doping control system. Doping substances are detected in the blood using special devices. Doping control is usually carried out by employees of special laboratories operating in large cities. Next, sanitary chemical analysis. It deals with the detection and quantification of toxic and hazardous substances in the air of industrial enterprises. When the rules of technical safety and labor protection are violated in the production facilities, the issue of studying the composition of the air rises and are carried out by highly educated pharmacists working in the field of chemical and toxicological analysis. Specialists in the field of sanitary chemical analysis use methods of chemical toxicological analysis based on the same principle. The above four sections of chemical toxicological analysis are mainly applied in practical areas. These methods of analysis are used with equal success in relevant fields of sciences. In this regard, it is necessary to specify two types of analysis: pharmacokinetic and biopharmaceutical analysis. Pharmacokinetic analysis. It is used to detect the pharmacokinetic regularities of medicinal substances. Highly effective pharmacotherapy cannot be achieved without the well-known pharmacokinetic regularities of the substances. Pharmacokinetic studies are usually performed on laboratory animals based on model experiments. After a certain period after the injection of drugs into animals, the amount of these drugs in the blood of animals is determined periodically at intervals, and their fate in the body is determined. The determination of the concentration of drugs in the blood is still carried out by chemical and toxicological analysis. Biopharmaceutical analysis. It depends to determine the biopharmaceutical parameters of medicinal substances. In general, research in the field of biopharmacy is aimed at finding the form, type of drugs that can give high therapeutic efficacy and their optimal methods of being used. Comparative biopharmaceutical research for various drug forms is carried out only based on chemical toxicological analysis methods. Toxicological chemistry connected with other subjects. Toxicological chemistry is one of the core subjects of pharmacy. A specialist in the field acts as a chemistry expert. Toxicological chemistry feeds on a source that connects many subjects and develops in close contact with them. This subject is closely related to the following subjects: medicine, chemistry, biology, pharmacy, physics, and apparatus making. Toxicological chemistry, as a pharmaceutical specialty, started from the demands of medical subjects, primarily toxicology and forensic medicine, and it is still strongly associated with them because they use the methods of toxicological chemistry to solve many important problems. This subject is also closely related to other areas of medicine and pharmacology. The second area in which toxicological chemistry is closely related is chemistry. The fact that many toxic substances are composed of metallic and non-metallic compounds brings toxicological chemistry closer to inorganic chemistry. Organic chemistry includes several organic reagents, indicators, drugs. Recent advances in the synthesis of substances, as well as in the analysis of organic compounds by functional groups, have led to the emergence of new analytical reactions and methods. These reactions and methods are widely used in the practice of chemical toxicological analysis. This proves once again the strong connection between toxicological chemistry and organic chemistry. The use of many analytical methods in modern chemical toxicological analysis practice shows that analytical chemistry is closely related to this subject. The application of several physical and physicochemical analysis methods in toxicological chemistry, for example, extraction, chromatography, electrophoresis, colorimetric, photocolorimetric, spectrophotometric, and others, indicates its strong connection with physical and colloid chemistry. When explaining the mechanism of the process of the toxic kinetics of toxic substances, for example, absorption, distribution, and others, known concepts in physical and colloid chemistry: diffusion, osmosis, absorption, desorption, and these are used again. Toxicological chemistry is closely related to biological sciences. The main ones are botany and biochemistry. The fact that many poisonous plants are the objects of chemical toxicological analysis connects toxicological chemistry with botany. Explaining the mechanism of toxic and also the transformation of drugs in the body based on biochemical events and regularities shows a strong connection between toxicological chemistry and biochemistry. Toxicological chemistry, as one of the subjects of pharmacy, is inextricably linked with the subjects of pharmacy. First of all, we can mention the subjects of pharmaceutical chemistry and pharmacology. Many drugs and methods studied in pharmaceutical chemistry are also used in the practice of chemical toxicological analysis. Many plant raw materials studied in the course of pharmacognosy. Their corresponding biologically active substances and drugs have toxicological significance and are studied from toxicological chemistry. Toxicological chemistry is closely related to physics and instrumentation. By the way, some physical methods are also used in the practice of chemical toxicological analysis. The study of toxic substances by physical and physiochemical methods is not possible without the use of modern equipment. Therefore, the development of chemical toxicological analysis depends to some extent on the level of development of the instrument-making industry. As is clear from the summary above, toxicological chemistry cannot develop on its own without the help of many subjects. That is, it must operate within a framework of interaction. Those medical sciences, primarily forensic medicine and toxicology, raise certain issues that need to be addressed before toxicological analysis. Chemistry and pharmaceutical sciences, first of all, analytical chemistry and pharmaceutical chemistry, offer and present appropriate analytical methods to achieve a positive solution to the issues. Toxicological chemistry itself is not indifferent to the development of the relationship, which in turn has a positive impact on the development of other sciences. Thus, for the first development of the biopharmaceutical direction, in the field of pharmacy, he proposed and presents the methods of chemical toxicological analysis developed by him. Another important factor for the realization of these issues is the correct selection of specialists in the field of chemical and toxicological analysis. As mentioned above, toxicology is the study of toxins and their effects on the organism. The most important sections of modern toxicology are forensic toxicology, clinical toxicology, industrial toxicology, toxicology of poisons, and plants. Forensic toxicology is an appropriate field of forensic medicine. It studies the poisoning that results from the use of poison to kill him or her and others, as well as the poisoning that occurs as a result of accident. Due to the use of new chemical compounds in medicine, agriculture, household, industry, and other sectors of the economy, and the toxic properties of some of them, the role, content, and scope of forensic toxicology is constantly increasing. There is a great importance of toxicological chemistry in the study of various substances that cause poisoning in the positive solution of the problems facing forensic toxicology. It is also worth noting that the toxicological meaning of chemical depends on many factors. These factors include the toxic effect of this substance on the body, their widespread use in medicine and various sectors of the economy, their easy access to the majority of the population, and so on included. Toxicity can be studied from two perspectives: toxic dynamics and toxic kinetics. Toxicodynamics studies the mechanism of action of a toxic substance on the organism. Toxic kinetics, on the other hand, studies the situation and behavior of a toxin in the organism. That is, the process that takes place with it. In short, the absorption of toxins into the body, their distribution across organs and tissues, their conversion into appropriate compounds, metabolites, their excretion from the body, and so on. The study of such issues is a field of toxicokinetics. Information of the toxic kinetics of toxic substances provides a basis for the correct selection of internal organs and biological fluids for chemical toxicological analysis, objective evaluation of research results, and the solution of several other important issues related to determining the cause of poisoning. One of the characteristics of chemical toxicological analysis is different groups of research objects. These objects can be divided into the following groups. Objects are taken from the body. They are taken from the bodies of people who have died or have not died from the effects of toxins. These objects can be divided into two groups: internal organs, tissues, biological fluids, blood or urine, vomit, nails, hair, etc., taken from the corpses of people who died as a result of poisoning, can be shown. Such objects are used for forensic chemical analysis. And next, biological fluids, blood or urine, vomit, gastric lavage, and etc., taken from the body of persons who have taken a toxic dose of toxic substance, can be shown. These are used to perform laboratory diagnosis of acute poisoning. Objects in both groups will present objects that cause poisoning when ingested. This includes food scraps, food water, plant parts, medicines, various chemicals. This group also includes the air in residential or industrial buildings, where the poisoned person was before the poisoning occurred. Contact objects. This includes clothing, stains on clothes, glassware containing drugs, dishes with poisonous food, as well as items with traces of crime and other such material evidence. The occurrence of pathological processes in the organism which are not fatal and are not caused by toxic substances is characterized by poisoning, intoxication. Intoxication occurs under the influence of toxins and exotoxins and endotoxins. Damage or destruction of the body's biosystem under the influence of toxicant is called the toxic process. Toxicity is studied as a level of tissue, organ, organism, and population in biological objects where the toxic process develops. Poisoning can be mild, acute, and chronic depending on the dose. The dose is the amount of substance that enters the organism to cause functional changes. In mild poisoning, toxins that enter the organism once or repeatedly cause pathological process but are not vital, and symptoms of poisoning are observed for several days. Acute poisoning is caused by doses of a toxic substance. It can be life-threatening by disrupting vital functions of the body. In small doses, chronic poisoning occurs as a result of the long-term ingestion of the toxin. The ability of a small dose of a toxic substance to cause such strong pathological process indicates its toxicity. The development of intoxication is characterized by four periods: the period of contact with the poison, the latent period, the period of severe poisoning, and the period of recovery or death. Poison is characterized by two phases: toxicogenic and somatogenic phase. The toxicogenic phase is the period when toxins enter the body, where they are metabolized and eliminated. The somatogenic phase is a period of a complication caused by the poison leaving the body. Depending on the localization of the pathological process, intoxication can be local or general. During local intoxication, the pathological process occurs in the area where the poison is in direct contact. For example, inflammatory and necrotic disorders of the eyes and skin because of saponins, acids, alkalis, and etc. During general poisoning, the poison is absorbed from the area of contact and damages various organs of the body. All biological organisms are in constant contact with the environment. As a result of change in the environment, adaptogenic mechanisms are activated in the body to maintain its integrity, which is called homeostasis. Toxins primarily cause homeostasis disorder. Disorders of homeostasis don't occur due to very small doses of toxic substances. In this case, the detoxifying functions of the body are activated. Tolerance is the fact that the body is not poisoned by certain toxins. In modern times, toxicological chemistry is divided into two sections: biochemical toxicology and analytical toxicology. Biochemical toxicology studies the mechanism of action of toxic substances on the organism, the kinetics of absorption, distribution, and mechanism of their metabolic process, the mechanism and ways of transport of substances and their elimination. Analytical toxicology studies the ways and means of isolating substance from biological material and samples, purification of extracts from foreign substances, the analysis of substance in terms of character and quantity. Two indicators are important for the occurrence of toxic effects: the amount of the toxic substances and the duration of its effect. Depending on the concentration and time, toxicants are divided into two groups: concentrated and chronoconcentrated toxicants. Concentrated toxicants, the toxic effect of these substances depends on the concentration of the poison, not on time. For example, drugs Garayev-like substances, hydrogen cyanide. The toxic effect of homogenized substance depends on the time factor. These toxins enter the body slowly, blocking its enzymes system and disrupting metabolism. For example, phosgene, acetone, hydrogen sulfide, sulfur dioxide, aromatic hydrocarbons, and that's. The correct choice of analytical methods in the analysis of the characteristics and quantity of substances is an important condition for minimizing the negative results and maximizing the positive results, which depends on the sensitivity and specificity of the methods. The sensitivity of the analytical methods is determined by the ratio of the signal of the substance on the study to the baseline, and it's expressed as nanogram milliliter or kilogram of the biological object. The specificity of the methods allows distinguishing the studied substance from similar substances. The literature on toxicological chemistry sometimes uses the terms xenobiotic as well as toxicants instead of poisons. A xenobiotic is a foreign body that doesn't participate in the energy process that enters the body. The term toxicant has a broader meaning. Toxic means not only the ability of a substance to cause intoxication in the body, but also other forms of toxic processes. For example, those that have toxic effect at the cellular level are cytotoxicants, it's called. Xenobiotic differs in their toxicity. The smaller the dose, which is capable of causing pathological process in the body, the more xenobiotic is considered toxic. The toxicity of xenobiotic depends on whether it reaches the target organ, where it will have a detrimental effect, whether there is any communication between the target and the xenobiotic, and how important the target is to the body. The development of intoxication depends on the chemical structure of the xenobiotic, its state of aggregation, its solubility in water and lipids, its molecular weight and chemical activity. As the molecular weight increases, it becomes more difficult for the toxin to enter the body and distribute in the organs and tissues. Small molecule hydrophilic and lipophilic compounds, as a rule, easily cross the histogenetic barrier and don't encounter obstacles in the distribution in tissues. High molecular compounds, natural and artificial polymers, for example, that are poorly soluble in water and lipids, cannot cross the barriers and enter the tissues, and have no general toxic effects. Despite the large size of the molecule, lipophilic substances cross biological barriers relatively easily. As the size of molecule increases, so does the number and specificity of its possible isomers increases, and its activity start depend on conformation. Small molecule compounds don't show specificity because they have a limited number of isomers. A large amount of toxicants form a large number of isomers with different toxicity. As the size of the molecule increases, it is more likely to form a bond with a biological substance due to van der Waals forces. Chemical toxicological analysis plan. It is very important event. As it is known, each chemical toxicological analysis begins with a series acquaintance with the materials of the case and the development of a plan of research. A well-thought-out idea and well-thought-out plan are of great importance in the forensic chemical analysis of all material evidence, including the internal organs of a human corpse. Such a plan significantly reduces the analysis time and eliminates unnecessary conception of the research object and relevant reagents. If there is no research plan, the chemist expert can also analyze the biological material according to the substance to be removed from the list of poisons. Carrying out some operations, which are not very important in the practice of chemical toxicological analysis, leads to unnecessary waste of working time, inefficient use of the object of research, reagents, and equipment. Material evidence and biological material should be used sparingly when conducting chemical toxicological analysis because they are irreplaceable and irreplaceable. We must not forget that it is impossible to analyze the same kidney, the same liver, the same culture a second time. Therefore, all the objects of chemical and toxicological analysis are forensic bodies, forensic doctors, chemist experts. It is extremely valuable for professionals should be kept in special conditions, protected and treated with care. Reducing the time of analyzing and eliminating unnecessary use of the research object and reagents is possible only through a well thought out and carefully designed research plan. When drawing up the plan of chemical toxicological analysis, the condition of the case presented in the cover letter must be taken into account. It is necessary to take into account the information provided in the extract of the medical history, if any, and in the act of forensic examination of the corpse. Preliminary inspection of research objects and determination of their properties are of great importance for the development of a plan of chemical and toxicological analysis. It was our first lecture. Thank you for your attention.